Today, we are talking about a problem that, let's be honest, is the best kind of problem to have. It's the problem of massive runaway success. We're talking about sharding, what you do when your app gets so popular that a single database just can't take the heat anymore.
So just imagine for a second, your app is a hit. It's exploding. Users are flocking to it, traffic is through the roof, and your database is growing at a mind-boggling pace. Now, for a while, you can just throw more money at the problem, right? Get a bigger server, more RAM, more CPU. This is called vertical scaling, and it works until it doesn't.
Because eventually you hit a very, very real wall. Even a total beast of a cloud database, something like Amazon Aurora, tops out. We're talking around 256 terabytes of storage. And once you hit that limit, or maybe even the limits on how many reads and writes it can handle per second, you're kind of stuck. Queries start to crawl, and your whole app begins to feel sluggish.
When that day comes, you really only have one way forward. You have to split your data and spread it out across a whole fleet of machines. This right here is what we call sharding. It's an absolute game changer for scaling, but it also opens up a whole new can of worms, a new set of really interesting challenges. Okay, before we dive any deeper, we need to clear something up. You'll hear people use the words partitioning and sharding like they're the same thing. They're related, for sure, but they are not the same, and getting this distinction right is key. So, partitioning is all about organization. Think of it like taking one gigantic, messy bookshelf and adding dividers to organize the books by genre. You're splitting a huge table into smaller, logical chunks, say a separate partition for each year's worth of orders. But, and this is the important part, it's all still happening on that one single database machine. You're not adding more hardware, you're just making it faster for the database to find what it's looking for. Let's just put it side by side to make it super clear. Partitioning, that's on one machine, and its goal is to make queries faster. Sharding, that's spreading data across many machines. Its goal isn't just speed, its goal is true scalability. More storage, more traffic, the whole 9 yards. So simply put, partitioning organizes, sharding scale. All right, so you've made the call. You're going to shard. Now comes what is, without a doubt, the most important decision you are going to make in this entire process, choosing your shard key. This single choice dictates how your data gets split up, and it will have massive consequences for years to come. So what makes a good shard key? Well, it really boils down to 3 qualities. First, it needs high cardinality. That's just a fancy way of saying it has a ton of unique values, like a user ID. Second, it has to spread your data out evenly, so you don't end up with one machine doing all the work. And third, and this is crucial, it has to line up with how your app actually uses the data, so you can grab what you need from a single shard as often as possible. Let's make this really concrete. For a social network, user ID is a fantastic shard key. It's unique for everyone, and most of what you do is centered around a specific user. But something like is premium, a boolean, that would be a total disaster. You would have 2 shards, one for free users and one for paid. Guess which one gets all the traffic? And created at is also tricky, because all the new signups, all the new writes, would pile up on the exact same shard, creating a massive bottleneck. So you've figured out what to shard by. The next piece of the puzzle is how you're actually going to distribute that data across all your new machines. And there are a few common strategies, each with its own pros and cons. The simplest approach is called range-based sharding. It's exactly what it sounds like. User IDs 1 through 1,000,000 go on the first machine, the next 1,000,000 go on the second, and so on. This is actually great if you need to do a lot of range queries, but it is super vulnerable to those hotspots we just talked about. If your key is something sequential like time, all the new data piles onto the last shard. Now, this is pretty much the industry default, and for a very good reason. With hash-based sharding, you take your key, like that user ID, you run it through a hash function, and then you use that output to decide which shard it goes to. This basically scrambles the input, which means your data gets spread out beautifully and randomly. The only tricky part is when you need to add more machines later, which is where a clever technique called consistent hashing comes into play. And the third major strategy is directory-based sharding. This one uses a central lookup table, kind of like a phone book, that tells you exactly which shard holds the piece of data you're looking for. This gives you amazing flexibility. You could literally move one super active user to their own private machine. But all that flexibility has a cost. Every single query needs an extra network hop to check the directory, which adds latency and creates a potential single point of failure. So you did it. You solved your big scaling problem. Congratulations. But in the world of engineering, you almost never get a free lunch. By solving that one problem, you've just created a whole new class of complex distributed systems problems. And you have to understand these trade-offs. First up, hotspots. Even if you use a great hashing strategy, some data is just hotter than others. This is the famous celebrity problem. If you shard by user ID, Taylor Swift's profile is going to get thousands, maybe millions of times more traffic than mine. All that load hammers a single machine. The fix? You might actually have to build special logic to identify these celebrity keys and move them to their own dedicated shard. The next big headache is anything we call a cross-shard operation. So say you wanted to find the top 10 most popular posts across your entire platform. Well, since your data is split up by user, you can't just ask one database. Nope. You have to send that query to every single shard, wait for all of them to respond, and then stitch the answers together in your application. It's incredibly slow and resource-intensive. You have to get creative with caching or running these big queries as offline jobs to get around it. And finally, we have the monster problem of consistency. Inside one database, transactions are simple and reliable, but what happens when an operation needs to touch two different shards? Imagine a bank transfer between two users whose accounts live on separate machines. You can't use a normal database transaction. The best-case scenario is designing your system so you don't have to do cross-shard writes. But if you can't avoid it, you have to venture into the complex world of distributed transaction patterns, which is a whole other beast. Okay, we've gone through a ton of theory, so let's bring it all back to a place that matters for a lot of you, the system design interview. How do you take all this knowledge and use it to impress your interviewer? Probably the single most important rule when you're talking about sharding is knowing when to bring it up. Because if you jump to sharding too early in the conversation, it's a massive red flag. You have to earn it. You only get to propose sharding after you have clearly identified a bottleneck that a single, beefed-up database can no longer handle. Is it storage? Are you about to blow past that 256 terabyte ceiling? Is it write throughput, where the database just can't keep up with the incoming data? Or is it read throughput that even a bunch of read replicas can't satisfy? You have to justify the need before you introduce this level of complexity. And when that moment comes, here is a simple 4-step playbook. 1. Propose a shard key that makes sense for the application's primary access patterns. 2. Choose a distribution strategy. And you know what? Hash-based is almost always a safe, solid answer. 3. This is so important. Explicitly call out the trade-offs you're making, like how expensive those cross-shard queries are going to be. And 4. Show you're thinking ahead by mentioning how you'll handle future growth and the need for resharding. At the end of the day, sharding is one of the most powerful tools in our belt for building systems that can operate at a truly global scale. But it's also a tool of last resort. It brings a ton of complexity. So the final thought I want to leave you with is this. A single, well-optimized database can get you incredibly, surprisingly far. Know its limits? Absolutely. But respect its power.